Hello, my name is Zachary Goddard,
And I'm Madison Anderson.
and we're going to be demonstrating the decomposition reaction of a copper to carbonate hydroxide hydrate molecule.
Alright, so we're in MATLAB now. First we're going to bring down the scale, which we'll use to measure the amount of copper to carbonate hydroxide hydrate. And then second, we'll bring down our Bunsen burner, which we're going to use to heat our substance. And finally, we're going to bring down our last instrument, the crucible, and it can withstand high temperatures and is used during many lab procedures, but today we'll be using it to hold our substance for the procedure. Now we're going to weigh our crucible. It ends up being 88 grams, and we'll go into the materials section and click on the copper carbonate hydroxide hydrate substance and go ahead and input 5 grams for our procedure, and we'll reweigh it, and we end up getting 93 grams total, and we'll put both of those pieces of data into the lab notes to hold on to for later. Alright, so next we're going to put our crucible on top of the Bunsen burner and turn it onto a low flame, which is usually just one click. And we are going to watch as it gets darker by just clicking on the container and showing the inside of it. And it'll take a few minutes. You can see it's steaming now. It's releasing H2O and CO2. Alright, so now we know it's extremely hot, don't touch, and it is now a different color. And it was greenish blue and now it's black, and this is going to signify that it's a chemical change that's occurred. And now we're going to reweigh it, and it is now 91.32 grams, which is a pretty significant mass change, and we will discuss that in a few moments.
Okay, so here's the chemical equation for the reaction that we just witnessed. So we started with this big molecule here, the copper carbonate hydroxide hydrate, and after the reaction, that big molecule was broken down into 3 different types of molecules. One molecule of the copper carbonate hydroxide hydrate gives us 2 molecules of copper oxide and 1 molecule of carbon dioxide and 2 molecules of water. So also take note that the initial molecule is in a solid state, and the copper oxide is also in a solid state, but the carbon dioxide is in a gas, and the water is also in a gas, meaning it's in the form of water vapor. Now the decomposition reaction, which is the type of reaction we witnessed here, is a chemical reaction in which a single molecule breaks down into 2 or more different molecules. Now, due to the law of conservation of mass, the mass of the products must always equal the mass of the reactant. But as we saw, the mass dropped quite a bit. This is because the mass of the carbon dioxide and water that was produced was lost since it was formed in a gaseous state. The gas escaped from the rest of the substance since there was nothing to keep it in. As you can see here, I have an equation to show how much mass of CO2 and what mass of H2O was produced by 5 grams of copper carbonate hydroxide hydrate. So if you take those 2 masses and subtract it from the initial mass of 5 grams, we get 3.198 grams, which is very close to the value we got in late night labs of 3.327 grams. In fact, that gives us an accuracy of 96.1%.